Before we used Keras on top of TensorFlow, and now we are going to use PyTorch with the same example. So with PyTorch we have more control of the neural network structure, and here is how we do it. So now we import PyTorch libraries. Here the generate dummy data is the same as before. We just need to change here the dimensions of the inputs and outputs according to what PyTorch expects, not with what Keras expects. Here we need to convert the inputs and outputs from NumPy to Torch, which is this data structure used by PyTorch. Is what we are doing here. Then we will generate our model. We are using this way here, sequential, and we are defining our convolution layer with one channel as input, one channel as output, kernel size, stride, padding, which here is kernel size -1. We are not using bias. We are not adding an activation function. We are using this time the mean squared error loss. Before we used for Keras the mean absolute error. This time we are using the mean squared error. We are using the Adam optimizer, and here, so this we have our model, we have our optimizer. This is how we train our model. So we have the predictions model of X, loss. We calculate the loss function between the predicted and the desired, and then here we just print the loss. It's computed here. Then we need this thing here to the zero grad. There's a way in PyTorch to adjust the gradient. Now we are not going into detail here what this is doing. This is the backward. It is also necessary in PyTorch, and then optimizer step. So we will see this in many PyTorch models, and you can read from the PyTorch documentation what exactly these things are doing. And then we will have our predictions. We have our weights. We can also save our weights, and here we are plotting the output of the neural network, the weights, and we observe that we have very similar results with the Keras. So basically we just try to reproduce the same example but using PyTorch instead of Keras. As I mentioned before, instead of a convolution, many libraries they use the cross correlation. So we can see here in PyTorch documentation we have the convolution 1D, and here we have this cross correlation operator, and it's not a proper convolution. Just some details that we need to have in mind depending on our application.